In the last session, we discussed about transformer and in theory what transformer is and how it is different from uh, other sequence to sequence architecture, including decoder architecture. And we, in terms of timeline, we started with a idea of language models, and I've given the idea what language models is and what is the high level pipeline for coming up uh, with a language model, train a language model, neural network based specifically a language model. And in today's demonstration as well, you have seen how Mayank has shown one simple language model using LSTM. So we started with that, and then we had a discussion of sequence to sequence model, uh, neural network based like recurrent neural network. Then we discussed about LSTM uh, and GRU, which uh, effectively solve some of the problems that vanilla RNN or basic RNN have with respect to the long range dependency. And together, this sequence to sequence model uh, have have two problems like context vector bottleneck and sequence processing. These two problems, later on we discuss how researchers have solved this context vector bottleneck using attention mechanism to remove this. And then for sequence processing, alternative transformer based architecture have been proposed in 2017. So these two, and then we discuss how transformer works, how it converts uh, everything into algebraic operations so that parallel computation can be done and model can be trained on a large data set. So that was the discussion, and then we discussed some of the key concepts in transformer, like what encoders do and decoders having self-attention mechanism. And we talked about positional encoding and multi-head self-attention. And then towards the end, Mayank beautifully explained autoregressive decoding, uh, what autoregressive decoding is, and then uh, how masked self-attention, masked multi-head self-attention is used in the decoder and why it is used, and then encoder and decoder attention which uses in the decoder part. So this was we had discussed last time when in the last session when we discussed about the transformer architectures. And in today's session, what exactly we are going to discuss. So we'll the whole session is divided into some small chunks. We'll briefly discuss about large language models, which uh, have the backbone from transformer. And because from conclusion from last lecture was that okay, so when transformer came into the picture, it was it enables the to have a pre-trained model in a language side, in the text side. And once the architecture is proposed, we saw a lot of transformer based architectures like GPTs and llamas and other architectures have been seen. So we'll talk about something about LLMs, what LLMs are, and what LLMs do, and then we'll then we'll see the limitation of LLM, what LLMs can't do, and then we'll talk about retrieval augmented generation based model, which basically uh, RAG. Uh, so LLMs are augmented with a RAG based approach for so that retrieval uh, can be grounded from the knowledge itself, and model do not hallucinate or do not generate any random output in a layman term of, if I would say. So we'll talk about RAG based model and basic idea of what RAG based models are there, what are the terminologies involved, and uh, what high level pipeline is there, and what if you want to build a RAG based model, what basically theoretical steps that you usually do, and uh, the related concept we'll discuss in this session. And towards the end, we'll talk about, so this is our first part we had covered last time and we'll start today as well. And then this will be the second part of the session. In third part, we'll talk about one of the framework called Olama. I'll give you a brief idea about Olama framework to run your run some of the LLM models locally on your system. And tomorrow's session will I'll we will see some of the RAG-based model, the popular RAG-based model that are or I would say limited generative AI models that are popular for teaching and research. So we'll see some of the tools that are openly available, generative AI models that you can use it for research purpose, and uh, that will improve your productivity. Okay, so that is the idea of today's session and the tomorrow session that we are going to have. So we have seen transformer as an architecture having encoder and decoder part, and in the encoder side you have many encoding layers, and you give the input and then it passes to each encoding layer that we had discussed earlier, and then the encoded output then again converted to two matrices, key and value, and then it is given to the all the decoding layer, and then decoder uses auto regressive approach to generate one output at a time, and all those layers involved trainable parameters in terms of weight. So when we say so when transformer came into the picture, they their ability to process sequences in parallel using the self attention mechanism and capture the long range dependency that we had discussed have become the foundation of the large language models, LLMs, which are transforming the AI applications right now. And you have seen now you are seeing a lot of LLM based models that are there, and for different purposes. And simply just scaling the number of parameters and training on massive data sets having domain knowledge from diverse field, the transformers uh, have evolved into LLMs. So one question was there: what is as language model, as small language models and large language models? And Mayank already gave an answer to it. So basically, if you talk about large language models, so it have uh, a huge number of parameters uh, uh, compared to small language models. So a basic difference between those two is based on the number of parameters, and obviously those number of reduced number of parameters or large number of parameters depends on the type of task and type of uh, problem you are working on. So LLMs have evolved after when transformer have introduced in 2017. Some of the examples of LLMs like GPT-3 was proposed by OpenAI in 2023 that have 175 billion parameters, and GPT-3 can generate human-like text. It can perform the translation, even write the code, and lots of other tasks, NLP-related tasks it can do. Then another one was the BERT, which Mike was talking about, that a bidirectional and transformer encoder, which is pre-trained on the large corpus of data. Uh, Specifically, it is used for the encoding purpose. So it has the encoder only part of the transformer. And there is another variant called T5, which uh, frames all the NLP tasks as a text-to-text problems. So it has the encoder decoder transformer architectures. And some of the key enablers that were there that enables the transition from transformers to the LLMs. So one is the scalability. So since transformer can perform all the algebraic operation in parallel, thanks to GPU that do the parallel processing, it allows to train models with lot of huge number of parameters efficiently. And once it is trained, it enables that, okay, so you can use that pre-trained model uh, for specific tasks that have only minimum data or specific data. Right. And that hardware advancements like GPUs and TPUs also were reasons that now you are seeing a lot of large language models trained on large corpus. So before that, before 2017, there is the NLP field was uh, on a personal note, I would say it was not as popular as the computer vision side was there. So you might have seen that lots of image models were coming for object detection and various uh, video or audio related, video and image related task. However, the NLP field was slow and was uh, mainly uh, based on the classical NLP approaches that were there. But once transformers have been introduced, then in 2018 first GPT model was introduced, and then BERT GPT-2, and then 2022 2020 in May GPT-3, then uh, later on DeepSeek R1, Llama GPT 4o, and a lot of other models are. So this timeline is still, I mean, now it is outdated. So in 1 year, there have been more other models have been proposed as an LLM. Right. This is just a comparison of GPT 1, 2, 3 models. So it is trained on 840 GB, 8 million web pages. GPT-2 have been used, and GPT-3 have been trained on more than 570 uh, gigabytes of data, and number of parameters that are there, and the number of decoder layer that are there in this GPT models. So, okay, so let me open the chat section as well. If there is any questions, you can write it on the chat. So that will I will randomly I'll check the chat for any questions that are there. However, those LLMs have some limitations. So basically, there are very those LLMs that you see, classic LLMs that you see, have various limitations. Like they have limited knowledge, so they are trained on specific data, and they learn from a fixed data and then stop learning. So you have a learn model from data, and there might be factual errors that they are producing. So because of the outdated or missing knowledge, and LLM might be trained on the last year and doesn't know this year events or new facts. Let me give you a demonstration of it. So if you we'll talk about llamas, Olama, then you will see uh, demonstration there. That however, I'm for a large language model, I'm using Terminal and I'm using Olama. I'll show you how you do it. Uh, I'm not giving the demonstration from Chat GPT because it is already using RAG based compound AI system behind the generation of the output. So now the latest GPT models, y- and then the interface like Chat GPT, Grok, or DeepSeek, or Cloud, they have a RAG base uh, backbone to generate the output, and also they find out the relevant information from the internet. Uh, the limitation that I was talking about, the static LLMs, the and the earlier that has been proposed. So even if you, let's say, uh, download a large language model in your system, and then if you run it, for example, let me run this small 1 billion model gamma 3, and with this static model, if I ask any questions, for example, who won the ICC T20 2016 World Cup? So unfortunately, there has not been ICC T20 World Cup in drawn India. So the model is not able to answer because it is not trained. Uh, it is outdated. The information on which the model, that particular model Gamma 3 that I have downloaded, was trained up to 2023 data. So it does not have any information, the latest information about it. And uh, let's say if you are trying to build an application based on an LLM model, and that LLM model was trained on the past data, you might see the information that it is giving you might be outdated, or the information is not available. So that was the limitation of the classical LLMs, uh, LLM model only. Uh, However, nowadays the Grok and DeepSeek and other models, other interface that you use for accessing the LLMs, that are not classical LLMs, that are now used to a compound AI system or a RAG. They use agentic AI to uh, intelligently generate a response based on the type of query, and finding out the corresponding response. So they may have a factual error, and they have a limited reasoning and context constraint because they have trained on fixed data, and they are hard to adopt to new data. Right? For example, uh, one example I have demonstrated. And one example here it is given. For example, let's say if I ask a classical uh, LLM about I want to plan a vacation and want to know how many vacations days are at my disposal. So now classical element doesn't know about a number of, so does not have personal information about myself, and so uh, it does not know how many vacations days are currently I am having. And uh, so it when you give something query that needed some specific data to answer, then your LLM might give you wrong answers, wrong answer similar to this that here uh, it is giving. For example, see here the response is it is giving, unfortunately there has been an ICC T20 World Cup. There has not been an ICC World Cup in 2016 yet. The tournament is planned to take place in 2025. So you can see there is no meaning of this sentence, and the LLM is basically hallucinating and generating a random response. So when we say LLM is hallucinating, so there are two basic problems with the classical LLM. One is the outdated or missing knowledge, and second is hallucination. And when we say hallucination, so model hallucinate. So there are two things that model is doing. One, it giving you a fact which is false, so factual error, also a type of hallucination. And the model is might be generating a response that does not exist. For example, here where your model is generating this last line that tournament is planned to take place in 2025. So because LLMs are nothing but a language models that is generating one token at a time based on the previous context, right? So uh, hallucination, it means that it is generating some random information which is uh, which is not true and which might not exist, or it contain information which is having the factual error. So to address this issue, uh, to address this issue, RAG based retrieval augmented generation uh, based models augment the LLM with a retrieval step. So what happens uh, whenever user asks a query, uh, your UI means uh, the system that you are looking at it, and the client through which you are interacting with LLM. For example, Chat GPT. You are writing that query there, and the QA system that uh, this is important. Just remember QA system. We'll talk about it later on. Take the query and find out the task specific document. So it might be there that in that query might require some specific document, and this query initial prompt is augmented with a relevant doc. So retrieve with the retrieval step. So there are two things. One, these task specific documents are retrieved, and relevant documents are embedded with the query, and then it is given to the LLM to generate the response. So this is an informal idea of RAG base. We'll talk about how formally RAG system is defined and what are the terminology. So RAG, uh, the model basically can access to external data. So the LLM is already trained on some gigabyte data set, and however when query is given, जब query दी जाती है तो model on the fly access to external data, and it uses this relevant data as a context when generating an answer. So query is augmented with the context which is retrieved from the document, and this is given to the base LLM to generate the answer. So basically, in practice, it means that when a question is asked, system first search a knowledge base. So whenever question is asked in form of uh, prompt, so if I talk about how it level pipeline, user submit a prompt, right? Then your LLM uh, converts that prompt into a query, and it submit query for a context that is the relevant information to the data source. Data source could be a knowledge base, or could be a database, and then database from the database it gets a response with relevant context, and then uh, LLM then consume this prompt and the context, and then it generates the response to the user. So it consume prompt plus context and then generate the response. So so basically, when a question is asked to LLM, the system, instead of directly giving the response, it first searches a knowledge base. How it searches? So there are various approaches. Either you can provide as an attachment those document, like nowadays the LLM UIs that you are using, ChatGPT or other applications, you see that plus sign to add or attach file. For example, let's say if I uh, go to Brook, then you see here there is a symbol for attach. Similarly, on ChatGPT you have plus. So now you can upload a file, right, for access for to allow the access of external data to the LLM. So when question is asked, or if you are not providing in data, then that system first searches a knowledge base. It could be uh, internet links, web pages, and then feed those passages into a language model, and then LLM then generates a response based on both query and the retrieve information. And this way, uh, basically the RAG outputs are grounded in real data, and it can be up to date, and which reduces the hallucination. So for example, Grok, which is one of the effective uh, LLM that uses RAG approach as well. So if you ask same question that we had asked to the classical LLM, who won the T20 uh, World up to 2016. So if you run this prompt, uh, see here it is writing searching the web, and there were uh, some results that relevant information it has collected, and then it generated the response based on the context retrieved from the CC here. It has used 45 sources to get the relevant information, and then from the relevant information it generated the responses, which is not which is true and the grounded, uh, and not hallucinated as classical LLM was doing. I hope everyone is listening today. So everyone is there today, yes or no? Are you following me? Yes. Okay. So if we define a RAG based model, so it is an essentially it is a hybrid model. It's a hybrid model that combined so it combined two types of memory. One is parametric memory, and when we say parametric memory means LLM's weights. So uh, on which because LLM was pre-trained on some huge data set, and the weights were learned during the training time. So that weights known as a parametric memory with non-parametric memory. So non-parametric memory means the external data that you give, either you give to model or model automatically find out from the web, like Grok is doing, as an external knowledge index. So uh, it is basically a specialized model that integrate retrieval and generation process uh, to boost the performance of the LLM. And the whole basic purpose of RAG is to improve the contextual accuracy and relevance of AI generated content. And how it does it? By incorporating the real time external data. By incorporating real time external data. And RAG basically ensures that the responses that are generated by the LLM are accurate and up to date. So, in short, if we talk about RAG, so RAG first let us inject the fresh knowledge into LLM without retaining the model. So we do not retain the model again with the new knowledge. We inject the new data, and then LLM response responded. So they'll so basically what benefit you have using RAG based generation? So you have so there are lots of benefits, like uh, you can access up to date knowledge. It improves factuality, that so it is does not hallucinate. So I would not say it does not hallucinate. It might hallucinate for some extent, but it reduces the hallucination compared to basic LLM. And it can handle domain specific queries. So what you can do, you can uh, use LLM and create an application that generate Domain specific query, for example, like Mang was explaining about the legal documents, you want to retrieve the information from those legal documents, then you can use RAG based approaches. So uh, RAG is RAG based systems are in basically invaluable when answering the questions about specialized and proprietary data that is not there in the public training corpus. So for example, uh, if a company in their even company, or let's say institute, uh, having an internal data, and HR can, so we can create a HR chatbot, or basically assistant chatbot that can use a RAG based approach to read from company or the institute uh, information, might be from the web page of the institute, or some documents, or it could be institute regulation data, like UG regulation, PG regulation, or if you're talking about company, then company handbooks and internal FAQs. Then uh, those chatbot can give the answer uh, based on that specific data as well, and we do not need to train LLM again. We just inject this data to the LLM to give the response uh, domain specific. And you don't and you can update that knowledge base, so you can keep all the specific domain specific data into a knowledge base, or you can give it on the fly, like attachment to the query, right? So formally, if I talked about RAG based systems, there's the core component of RAG based systems are, so if you talk about core components of a RAG system, so there are three level phases are there. So RAG have three phases. One is the data injection phase. So data injection phase, and the second phase is retrieval, and in the third phase is generation. Right. So data ingestion, basically, it also known as a pre-processing and chunking. Basically, in this phase, what happens? It gathers and process your source document into manageable pieces. So ऐसा नहीं कि आपने PDF दे दी या वेब से sources से raw data से collect कर लिया. So it directly uses that data. It performs some pre-processing tasks, and it splits the whole data into manageable pieces called chunks, right? And so it starts with data ingestion, and then in the second step, second phase, embedding generation is done, and in third stage, vector storage uh, is used to save those generated embeddings. Then there is a another component called retrieval engine. This is the core component which retrieves the relevant doc from the vector database. And from retrieval engine, next, once the relevant doc is find out, then the prompt augmentation is performed, and then language model generation. So basically, in practice, in real world, this forms a pipeline for RAG-based system, starting from data ingestions to embedding generation, then the vector storage, then retrieval engine, and then the prompt augmentation, and then generation. So when we, if we closely examine each those pipeline, so when we talk about data ingestion and chunking, okay. Oh, okay. So let me repeat once again. So if we talk about a RAG-based model, so unlike classical LLM, it is a hybrid model. So I'm just quickly recapping what I've said. So it is a hybrid model which basically combines parametric memory, which basically the LLM weights that LLM a pre-trained model which is there with having learned weight with the non-parametric memory. So basically, what happens? Uh, you give external data, either you give or the model find out from the internet, or your application find out from the internet the relevant sources, and it combines those two memory, and then it integrates retrieval and generation process to boost the performance, right? And there are mainly broadly there are three phases: RAG based retrieval, augment, and generation. So in re- uh, there are three phases: data ingestion. So in the data ingestion, you pre-process the external data and perform and you split into manageable pieces. So you divide into some chunks, and there is a retrieval phase. So from those chunks that you have divided, based on the query, it is identify which are the uh, relevant document for generating the response, and those relevant document again uh, augmented. So it is that's why it is called augment generation. It is augmented with the prompt. So prompt augmentation happens, and then it is given to the LLM. Then LLM generates the answer. So uh, a refined pipeline would be data ingestion and chunking, then embedding generation. So it is not like text data directly given as collect so collected and given as a context to the model. Obviously, embedding generation is happen, and then after embedding generation, it is stored in a vector database, and there is a retrieval engine, and that retrieval engine could be simply a program, or again separate LLM if we talk about agentic AI based concept, which find out the relevant documents from the vector database, and those documents in form of in form of context are added into the prompt. So prompt augmentation happens, and then the language model generates the output. So step, for example, data ingestion and chunking. Okay. So in data injection and chunking, first we collect the knowledge source, and so we collect the knowledge source, which could be, let's say, a Wikipedia pages, or PDFs, or internal docs, etc. And this raw files, once these raw files are collected, this raw files must be processed into smaller pieces that system can handle, right? So this typically involve chunking, or you can say text splitting, right? And this chunks basically, you can think of it as a is paragraphs, or sections or fixed text windows size, fixed size text window. तो पूरे टेक्स्ट में से कुछ कुछ मतलब फिक्स एक विंडो हमने डिसाइड कर ली, and that window might be your fixed size text window, that known as a chunk. And there is no I mean straightforward way to define what will be the good chunking for it. So for example, let's say if you have a document of PDF document that you attach having six pages and having 10,000 words, or let's say 5,000 words, then what so you could have a chunk where each chunk having uh, 200 words, or you can have chunks having 500 words in each. So if we say what could be a good chunking, then there is no straightforward answer, but we take a trade-off between balancing a context and manageability. So basically, good chunking basically balances between uh, context versus manageability. Manageability means a size of uh, chunk that you can manage in terms of memory or the processing. And each chunk should be semantically coherent on its own. So basically हर एक चंक भले से वो एक पार्ट है उस टेक्स्ट का, लेकिन उसके पास खुद की कुछ इन्फॉर्मेशन होनी चाहिए. So it should contain some information on its own and enough to produce the uh, enough to give the give LLM some input. So for example, if a document have 1,000 words, so you might split into 200 words paragraph, and there might be some slight overlap as well. So and then so that each chunk can be encoded, like, and there are libraries like LangChain or Llama Index that can handle this splitting. So there is in uh, LangChain there is directly a library having recursive character text splitter or sentence based method, and that basically chunks your data. And once the data is chunked into manageable pieces, small pieces, uh, then the second step, embedding, is generated. And from the day one of my lecture, I'm saying that text is directly not given as an input. They are transformed into embeddings. So once chunks are prepared, so sorry, chunks are embedded. Embedded means they uh, they are converted into numerical representation, basically high dimensional vectors that capture the semantic meaning of the chunks. ठीक है, so text को high dimensional vectors में convert किया जाता है, and there are a lot of options to do it. Can you write? Can you tell me some of the names for embedders? Or let's say if you have a text chunk and you want to embed it into a high dimensional vector, what are the possible options? Oh, okay. Uh, just a second. Let me. Okay, if everyone is facing the voice break problem, okay. So I was asking that. Okay, so once the chunk uh, has been created for the data. Those chunks, basically the uh, text chunks, are converted into numerical representation. And from day I have started the lectures on language models, I have said each word is represented by that high dimensional vector known as a word embedding. So we do not process those chunks directly, we convert it into embeddings. So what even from the previous session of Mayank's and mine, uh, you can guess what type of embedders we can use. So what are the options for embedders? What do you think? What uh, which model you can use for embedding? Okay. Any other? Bird? Yes. Or variations of word, variants of birds like sentence bird or all. So uh, once you perform the embedding, then this chunks are basically each chunk have its own dense vector, and these vectors are what the system will search to find out the relevant information. So once you have uh, those chunks, text pieces, for example, starting with let's say a text start with he is and so on, a text is going on and the corresponding a vector is there, high dimensional vector for that particular chunk. So the dense vector is basically associated with each text, and uh, so you might have, let's say, 1000 chunks of data. So basically you have a vector database for each chunk, and instead of working directly on the text, we embedding, uh, we find out the relevant information using the embedding. And there are two types of embedding, broad embedding approach, two broad categories of embedding approaches. One is called sparse and another one is dense. So traditionally bag of words or bag of word representations that are there, they generate the sparse embeddings, and they have less semantic meaning in the text, because bag of words basically just count the occurrence of the words and put the numbers corresponding to it, whereas in dense you use so other options like tf-idf is also there, bm25 is also there for sparse. For dense, like Amit said, Amit responded with but or but variants as well, like sentence but. This can be used to generate the vectors that have the context as well, that capture the context. So RAG system typically uses dense embedding as they capture the meaning beyond the exact word match. For example, let's say uh, heart attack word is there, and myocardial infraction is there, which are closely related in healthcare terminology. And but model that will generate the embedding will keep them closer in the word space. And this quality of the embedding is crucial, and it affects the retrieval relevance. So when you are creating a RAG based model, picking a good pre-trained model is an important step. So embedding model is one of the key step in uh, creating a RAG based system. And then once this vectors, uh, yeah, embeddings are generated, they are often stored in the vector database. So this embeddings uh, are basically kept in a vector database, and those vector database basically uh, are optimized to support efficient similarity search. So basically when हम करेंगे क्या कि जब हम कोई क्यूरी है तो उससे करस्पॉन्डिंग हमें जब रिलेवेंट डॉक्स निकालने होंगे, तो रिलेवेंट इंफॉर्मेशन निकालनी होगी, so we'll perform the similarity search, and these vector database are basically optimized for those similarity search. So there are popular vector stores are there, like Faz is there, which is Facebook AI vector store, and then some other options are there. Okay. So these systems can index millions of vectors, and it can perform approximate near neighbor search at high speed. Okay. So and some vectors database also store the metadata and the actual text chunk as well. So you might have a vector data which not only consists of embedding. So for example, embedding is there, which is a vector of numbers, let's say 0.1, 0.04, and so on, 0 minus 0.3, and so on. And corresponding text is also kept, which could be just chunk of document that for which corresponding embedding is there, and the source as well. Source could be document ID from which this embedding is generated, right? So these are kept as a storage, and this basically vector database, uh, in summary, it's basically your non-parametric memory is there. So once so those embeddings are generated and kept it in the vector database, and that there is one important component called retrieval engine. So once a query come, uh, so whenever a query comes, RAG performs a vector search. So vector search means from the vector database, it find out which document or which embedding or which vector is similar to that query. So obviously that first user का जो भी question होगा, user questions will be converted into query vector. So user question is also converted into query vector. So and how will you get the query vector? Again, using embedder. So you embed the user question text using embedder to generate a query vector. And usually you use a similar same embedder that you use for the embedding generation, right? So you use embedder that converts into query vector, and then this query vector is matched with your vector database, which one are similar to this query vector. Okay? And often it is a simpler approach is to do a cosine similarity, because in two vectors you can just find out the cosine similarity between those two vectors. And from the huge uh, set of vector database vectors, it find out the top k most similar chunks. Okay. So from those chunks that are there in the vector database, it find out the most similar chunk, and it returns the top k. So this basically a retrieval step, uh, find the piece of text most relevant to the query content. For example, let's say I've just written that who won the 2016 T20 World Cup. System might retrieve chunk from the recent sports article mentioning that the World Cup final and the winning team. जैसा हमने अभी ग्रोक में देखा था कि वो 45 डॉक्यूमेंट्स में से इंफॉर्मेशन कलेक्ट कर रहा था, एंड उसको उसने फिर it has performed, it might behind the scene automatically steps have been performed to generate the embedding and find out the top k most similar chunks. Usually that for retrieving the document, uh, often that retriever is a bi-encoder is there, like DPR. DPR means dense passage retriever. So one encoder maps query to vector and another maps document to vector. So instead of statically storing the vectors of document on the fly, uh, जो डॉक्यूमेंट्स कलेक्ट किए हैं आइदर एप्लीकेशन ने या फिर आपने अटैच किए हैं, those documents are converted into vectors, as well as the query that user gives are converted into a vector, and those retrievers are basically trained to bring the relevant query document pair closer in the vector space. And basically in real practice, what you can do, you can use a pre-trained DPR or fine tune a bi encoder on a related dataset. And most commonly, usually k is usually set to 5 or 10. So uh, it is common to retrieve the top 5 chunks or top 10 chunks. Okay. So there is no straightforward answer which you should use. The value of k is chosen empirically. Empirically means you perform the experiments and you uh, do the experiments with different numbers of k's, and obviously the more chunks will give you more context, but having more information there, then you will have more noise as well. So original rag experiments that have been done in the research uses k 5 or 10. uh, Sorry, I did not understand your question. How BERT model can work on a language specific in common? Can you elaborate your question? Then I'll come again on that question to answer. Uh, my question is also, uh, I hope these three steps are clear to all of you. Right? Data ingestion and chunking, then embedding generation, and then the storing it as in a vector database. It could be a static, so it could be predefined vector storage, or uh, on the fly we are storing it and converting those documents into vectors. Oh, okay, so actually today mm, there might be a problem due to the internet. Yes, three steps. uh, One is the data ingestion and chunking, then embedding generation, and then you store into vector database, and the retrieval engine, right? So these are the steps, or phases in the pipeline. uh, and usually, when you find out when a RAG based system find out the similar uh, vector searching, when it performs the vector searching, instead of using keyword search, so it does not perform keyword searching, it uses semantic vector search. So usually a RAG based system uses semantic vector search, because keyword search will try to find out the exact term, but there might be possibility that vector database that you have of relevant documents, uh, so of all the documents, you might not have the exact keywords. So for example, let's say if you have a query with having text with words called diabetic symptoms, and in your chunks there are no document having these two text. So if you perform keyword search, then no relevant document will be there. However, if you are using semantic search, it might retrieve a chunk about sign of high blood pressure, or even the word diabetics, which is not there in the chunk, but still it will find out some relevant document. So once you get the top k relevant chunks, then it could be 5 or 10, then prompt augmentation is happening. So in prompt augmentation, for example, top chunks have been retrieved, they are augmented with the original query. So original जो query तो query और prompt जो था user का, you add those top के uh, relevant chunks with it. Okay. And the chunks are treated as an additional context. So augmented or rewritten query might be something like this. One of the format could be this. So context, then context. So you have retrieved chunk one, retrieved chunk two, and so on. So that is your context, and then you have your query question. So user query goes here, and answer that generates the LLM generates it. So this way your model LLM model see both the questions and the relevant facts that are pulled from the documents. And this augmentation format can be basically uh, templated or structured for more clarity. So you can also define uh, your own uh, augmentation format. Okay. And in some systems usually it is simply prepend all the chunks, and some system might uses that these markers like context 1, context 2, context 3, context 5, and then or simply a bullet points to separate all the context and then the question. So good prompt engineering basically ensures that the LLM knows to use that context. And those RAG literature that on the researchers research that have been done, they often simply concatenate the query and the passage together. लेकिन कुछ frameworks like modern frameworks जो है like LangChain, it let it let you specify the templates for combining the query. So you can define your template कि ये query और जो retrieve text है इसको कैसे concatenate करना है और कैसे उसको कैसे कैसे लिखना है. And even you can give the template and you can augment the prompt and asking you can ask the model to cite the sources as well कि किस डॉक्यूमेंट से निकाला है इसने. So after prompt augmentation, uh, in the pipeline there is next step called response generation, where obviously for response generation you have a language model LLM. So augmented prompt is sent to text generation model, and this is usually a pre-trained sequence to sequence encoder decoder like BERT, T5, or a decoder only model, which is maybe if you fine tuned. So in literature basically जो classical RAG based system थे, I think in 2020 it was proposed. The generator was used but large model, which basically takes the input query and it concatenated all the passages as an input to BERT encoder, and then it generated the answer. And the basic output is basically just a string. But GPT, like जो अभी latest models हैं LLMs हैं, they uses encoder decoder architecture. Or you can use any modern LLMs as well for generating the response. There are various variants of RAG based model, so that those variants of RAG based systems are basically broadly. So this is done. Our RAG based pipeline is done, which have these steps: data ingestion and chunking, then embedding generation, then storing in a vector database, and which work as a non-parametric memory, then retrieval engine, which find out the top k most similar chunks, and those two top k relevant chunks are augmented with the your prompt, and then response is generated by LLM. And all those RAG based models have broadly two types of variants. One is RAG sequence and RAG token, right? So जो RAG retrieval augment generation का जो original paper था they have introduced two decoding method. So how you decode the output, how you generate the output. One is the RAG sequence, which basically this type of model uh, conditions on the same retrieved passages for generating the entire output. Basically it means that जितने भी आपके चंक्स रिट्रीव्ड हुए हैं उन सबको कॉन्कैटिनेट करके एक सिंगल चंक बना लो, सिंगल टेक्स्ट कॉन्टेक्स्ट बना लो, एंड देन from that single context LLM generates the output. Whereas in RAG token, uh, model generates one token at a time, and the token generated could be from different chunks, right? So for each next word the model might dynamically choose which passage or which chunk to focus on. And experimental shows that RAG token is works better than the RAG sequence. uh, However, RAG sequence is simpler and would be a faster one. And there are Hugging Face transformer libraries are there which implement both the variants, like RAG token for generation and RAG sequence for generation. These are the two libraries. And in Additionally, I would say in many application in real world applications where RAG based systems have been used, LLM and the retriever both are pre-trained model have been used, and data you can update without retraining. However, this whole RAG based system can also be fine tuned, right? So you can update the retriever and generator parameter, but usually uh, it makes the RAG system more complex. So usually you use pre-trained models. So if uh, want to build a simple RAG based system, sure. So I'll put the links in the canvas, right? And I'll put a PDF as well for the uh, from where I've referred that content, right? And also the sources that I've used. So if you want to build a simple RAG based model, so there are some steps. You collect document, and uh, collection of document could be done by the user or could be done by the platform as well. So if you see the Grok and this, they automatically collect document from the internet sources, right? So it could be automatically done by the application, or you can give the documents. So gather all the manuals, PDFs, uh, or documents. You chunk all the documents. Sorry. So you split each uh, document into paragraphs or sections, or it could be simply a 500 token chunks with some overlaps. Then you embed, right? Then you index. Indexing means store these vectors and their text in a vector database like Faz or Pinecone. Then query time, and the query time when user asks anything, you embed that query again using the embedder, and then search the vector database for the most similar chunks and return a paragraph from the manual. So return a paragraph or chunks from the documents manuals जो भी आपने retrieve किए, and then you format the prompt. So again, this formatting of prompt embedding, chunking, document collection, this pipeline can be done manually as well as, or let's perform these steps automatically once document is given, and at the run fly on the fly means on the runtime it is done automatically like Grok is doing, right? So this is idea about RAG based system. I'll share the document where you'll see the a complete document of it, uh, specifically about NVIDIA's view of a RAG pipeline. uh, have something like this. For example, if you have a database, so let's say this is your knowledge base is there. So up, so the two pipeline is there, document ingestion. So from this knowledge base, uh, pre-processing is done. and pre-processed documents are given to embedding model. So this is your embedding model. Again, a pre-trained embedding model you can use. And from this embedding model, the vectors you get, it is stored in the vector DB, right? And when user request, so user query and retrieval generation, how it happens. So a user write query on an app like chatbot app. So that query also goes to embedding model, and query and the embedding query, text and its vector is uh, used to search from the vector database, and from the vector database some documents were retrieved, which is top k documents. So your prompt plus retrieve document given to the LLM, and that LLM generates the response to the user on the app. So this is a high level pipeline. I'll provide you the document, then you can read about it. So this is uh, introduction of RAG based systems, and so this is also known as a compound AI system. So when I say compound AI system, it is basically a RAG based system. Now there are two approaches to uh, have it. You might have seen in the chat GPT or any grok system, uh, you can select the model type. It could be model thinking or the fast. So given a given a user query, and if we write a control logic to find out whether the information is need to be searched from the vector database, or it can directly LLM can generate the response. So whatever the control logic that you are writing for finding out the relevant tools or finding out the relevant documents, if that control logic is written as a program by the programmer, then it is basically a thinking model. Sorry, think fast models. Fast, it generates the fast response. However, if you give that control logic control to the LLM, so uh, you put another LLM for finding out the relevant tools and relevant agents to perform that subtask that query have, then it is a slow model of slow slow thinking model it is there, and which takes much time. So this is this is the idea of RAG based system. If you have any question, you can ask. Otherwise, uh, we can end the session today here. I will share the document. I will share that the document also contains link to the uh, RAG based approach, RAG based systems documents there. Uh, so you can read about it from there. Basically, whatever I've covered is summary from those links and summary from those uh, sources about the RAG based system. That ends today's session. One more announcement is there. You will have quiz on Saturday, second quiz on Saturday, right? Yes. Hmm, okay, so I'll discuss with the coordinator, and then uh, will inform on the WhatsApp group. Even the LLM that you can use. Okay, okay, I'll discuss with the coordinator, ma'am, and then I'll let you know. That even adding to your your write up, your chat, you can customize it with an in-house info, and you can also use LLM in your infrastructure only, as an in-house LLM. You do not need uh, API or uh, third-party LLM, third-party API or library to use the LLM. You can download the LLM on your system, and then you can build a RAG-based system using Olama framework. So tomorrow session I'll start with Olama framework. I'll give you idea about Olama, and then we'll move towards the some of the popular that are nowadays more popular in teaching and research. So we'll start uh, with how you can use LLMs offline. So like this, I was using Olama for using Gamma 3 1 billion, and this LLM is completely downloaded on my system, and it is even if I disconnect from the internet, it works on my system. So you can create a completely offline system for it, for your premises, for the security purpose. So we'll see a demonstration tomorrow with Olama framework for this, and if time, discuss some of the research tools that are quite popular. If you know, then it's fine. If you don't know, you might see one or two new tools that might be helpful for you. So thank you for this is yes. So tomorrow session I'll give you demonstration over those new tools. Okay, that is the end of the session.